if we're looking at question 65, in this case, we're actually just seeing data. The data set is this one here. And this is a data set just for one cycle. I've only got one entry for autumn, winter, spring and summer. That's it. So we're actually considering data for one cycle. Now the question is asking, what is the seasonal index for summer? So you'll notice in this row here, we have no entry. So they're asking us, what is the figure that should be assigned to summer? Now you've got 4 seasons. So the way we should do this is 1.2, that's my seasonal index of autumn, my seasonal index from winter, my seasonal index from spring, and my seasonal index from summer, which I don't know, so I'm going to call that X. Because I've got 4 seasons, they should total to 4. So when we add these 4 seasons together, so I add 1.2 and 0.8 gives me 2. 2 plus 0.9 gives me 2.9 plus X equals to 4. We're going to take the 2.9 across because we want to work out what X is. So that becomes 4 minus 2.9 and X equals 1.1. And remember, as I've mentioned in previous lessons, whenever we're attempting multiple choice questions, it's actually good practice to not actually look at the answers, to do the calculation, and then we'll come across and look at the answer, because you don't want to be swayed by some of the options in the multiple choice, because often the most common mistake is an alternative, and sometimes students see that the answer that they've calculated and they see that it's there and straight away they assume that must be the right answer. So I've got 1.1 here. So I didn't even look at the answers. I just went ahead, worked it out the way that I knew that I needed to do it, got an answer of 1.1. So C is the correct answer in this particular case. So that's the approach to that one. If we move to question 66, now this one, seasonal indices were calculated for each season for swimming pool attendances. So we've got data and we're going to calculate a seasonal index for example, how many people are coming to a swimming pool. So the question is asking, so what is a likely value for the seasonal index for winter? So we don't have any original data to calculate this. We've just been given options. So let's look at option A. Option A, seasonal index of 1.4 is suggesting that this particular season is 40% above the average. Now, in winter, we would actually expect swimming pool attendances to actually be down rather than up. If it was summer, most definitely I would think they would be increased. So I'm expecting something above 1. But for winter, because we have cooler weather, generally in winter, one would expect swimming pool attendances to actually be down. So if they're down, I would be expecting a seasonal index that is less than 1. So winter, cooler weather, you would expect swimming pool attendance to be down. So I'm looking for a value that is going to be, therefore, a value that is less than 1. And when I look at these options, this is saying 40% above average. This is saying 80% above average. This is saying 20% above average. D is actually saying it's an average month, so it's on par with what one would expect. And E is the only one that's less than 1. And as soon as I see that this is less than 1, I see that it's 0.4 less than 1. So this is actually 40% below average. So E is the only alternative I can consider because I'm expecting it to be less. And a seasonal index of less than 1 is the value that I'm looking for, and there's only one option there. So E is the only answer that is actually possible. So again, when I was interpreting what the magnitude of the different of seasonal indices, what it actually meant, this is showing this particular question is one of those interpretation questions. It's not getting you to calculate the seasonal index. It's actually testing. Do you actually understand what the value of a seasonal index means? And in the context of this example, what is the most likely or most appropriate answer? And that's why E is correct in this case.